there is a temperature at which there would be no molecular motion left. And you can't get colder than that. You can't get less motion than zero motion, correct? And so that would be the bottom, that would be the baseline of your temperature scale. Absolute zero is defined as no molecular motion, where it's so cold that even the molecules stop vibrating. And you cannot possibly have anything colder than that. Atom and molecule. I know you've all seen H2O before. That's the chemical formula for water. The subscript 2 here means that there's 2 hydrogens, right? It's kind of implied that there's only 1 oxygen. But point being with those definitions, on the periodic table, that's your list of elements. And elements can be broken down to the individual atoms. And so this water is made of 2 hydrogen atoms, 1 oxygen atom, that go together to make 1 molecule of water. H2O, water, is not an element. It's a compound that's made from a couple different elements. The smallest particle of a compound is the molecule. There's no such thing as an atom of water. Water's a compound, therefore you can break it down to the molecule size. If you break it down any further than that, you're splitting them apart into atoms. But it would cease to be water at that point. There's a lot of, it's a little awkward, I guess I should say here at the beginning a lot of times, with making the distinction between atoms and molecules, so just be aware of that. So when you're reading problems or reading notes or reading things on D2L, be careful around atoms and molecules. It's a very common error. Question? All right. Next page. Starting in just a little bit on calculations. Matt, how much time do you need?
15 minutes.
This part about significant figures. Is a way to assess numbers that you have, measurements you make, or numbers you calculate, so that you write down your answers showing how reliable that is. Not just numerically what the answer is, but whether it's precise or approximate. The whole idea behind science is that it's repetitive. And that if somebody takes compound A and compound B and mix them together to get compound C, then anybody ought to be able to follow the same steps and get the same result, correct? It should be that systematic. It should be reproducible. Right down to the amounts that are used and formed, it ought to be reproducible. And so the whole idea behind significant figures is that when you do a process or you do a calculation, you show in your answer how approximate or how exact, how precise that result is. So it's not so much about the number, the value of the number, as it is whether it's approximate or exact. So for example, if something weighs 4 pounds, we're not worried about is it 4 or 4.1 or 4.2. We're worried about is it approximately 4 or exactly 4, and how you show that in your number. All right? So this is broken into categories. The first category being how to handle making your own measurements. And you've got this ruler that's marked off as 1, 2, 3, 4, 5, 6. Let's just say that that's in meter units. And you've got these shaded sections, segments labeled A, B, C, D, E. Look at segment A compared to the top ruler. How long is it?
$4.7.
We're at 4.5, we're at 4.7. Anything else? Just to be different, I'm going to say 4.6. But the point is, it's 4 point something, right? When you make a measurement, like you're doing here, you want to estimate one place beyond what's obvious. This is obviously 4 point something, correct? And even though we're not quite sure what that something is, different people are going to see that and read that in a slightly different way. 4.5, 4.6, 4.7, any of those are better than lopping it off at 4 or rounding it up to 5, correct? You estimate one place beyond what's obvious. That's the rule. Estimate one place beyond what's obvious. So if this ruler is marked in units of 1, then you estimate to units of tenths. 1 decimal place more than what's obvious. What would be the length of B on the top ruler? 4.5, good. C on the top ruler.
4.3.
4.2, 4.3, yeah, something like that. D, 4.3, 4.4. E on the top ruler.
4.
0.0. We've been reading this, A, B, C, D. We were always reading 1 decimal, correct? Because that's the limit of the ruler. You're not going to quit doing that just because it happens to fall exactly on the line. So not 4, but 4.0 would be the right reading there. And I know that sounds a little picky because really there is no mathematical difference between 4 and 4.0, right? There's no mathematical difference, but there is a big difference in terms of the precision of that measurement because it's always assumed that you've got a little bit of fluctuation, a little bit of estimation in that last reported digit. That last digit is a little bit subjective. So when you say it looks like 4.0, that's really saying it could be anywhere between 3.9 and 4.1. It could be off by a tenth depending upon who looks at it and how they look at it. It could vary by as much as a tenth. But if you just say 4, that means it can be anywhere between 3 and 5. And that's not what you mean when you've been dealing with this kind of a ruler, correct? So just saying 4 meters, you're sacrificing a lot of precision that you really do have. As best you can tell, it's dead on at 4.0. And by putting the 0.0, you show that extra precision. Significant figures is not about the magnitude of the number. It's about how reliable is that number. To what decimal place is it trustworthy? And that's where we have the difference between 4 and 4.0. question with that? The bottom ruler is a little bit better. It's numbered in increments of 1, but it's actually hash marked in tenths. So if it's marked to the first decimal place, then you should be estimating to the second decimal place. Look at C. Line C on the bottom ruler. What does that look like? 4.2? 420. That'll be better. If the ruler's marked to 1 decimal, we should be estimating 2, even if it looks like it's on the line. D, bottom ruler, 4.30. And E on the bottom ruler. 4.00. Good. E looks like it's exactly on the 4, and as best we can tell to 2 decimals, it looks exactly on the 4. And so you show that as 4.00. Go ahead.
So why wouldn't you use 2 decimal places with the top?
Because it's not giving you any decimal places. It's only showing the limit there is 3, and then there's nothing else indicated. And so anything that's out, say this is the end point of it, you're estimating that first decimal. And you only want to estimate 1 decimal place. So, for example, with these, this was absolute, this was estimated. But using the better ruler, these were absolute and that's estimated. You're estimating 1 place beyond what's given. And so you want to think of it in terms of how precise is the ruler. If it's marked to tenths, you estimate hundredths. If it were marked to hundredths, you'd estimate thousands. 1 extra place. Is that answering your question or not? Okay. Other question with this? All right. Over on the edge, you've got a thermometer type thing. What's the temperature? 1, 2, 3, yeah, okay. .3 or 14.2, depending on how you look at it, right? But you should definitely have a decimal place there, because just calling it 14 is throwing away some of your ability to read that instrument. Yeah. But whether you see that as 14.2 or 14.3, either one of those estimations is better than just calling it 14. Do you see that? Question about that?
I was just stretching,
I'm sorry.
I was just stretching.
I didn't hear you.
I was just stretching. I thought you.
Oh, okay. All right. All right. All right. So now the next section then is reading given numbers. This would be not making your own measurements, but somebody else has made measurements and they give them to you on paper, and you've got to look at that and assess which parts are real, reliable, measured digits, and what things on there as just placeholders to locate the decimal, and therefore not real measured quantities. So you've got rules for that. When you're looking at numbers on paper to figure out which of those digits count as significant figures, then all of the digits 1 through 9 count as being significant figures. Because if you see a digit 1 through 9, somebody measured that digit. Those are not ambiguous. Zeros can be ambiguous because when you round things or estimate things, you typically wind up with round numbers with zeros on them. And those are very often placeholders. But it's safe to assume any number 1 through 9 that somebody gives you in the numbers really was a measured quantity. So there's no question about that. It is the zeros that you've got to be cautious about. And I'm going to break these into three categories, what's called leading zeros, middle zeros, and trailing zeros. And we'll look at the patterns of what applies to them. First of all, leading zeros. This would be things like 0, 0, 0, 7, 2, 3. They're called leading zeros because that's the very first thing you see. The zeros come before other numbers. Zeros like that do not ever count as significant figures. Apparently somebody measured the 7, the 2, and the 3, but those zeros are just placeholders. For example, going back to what we were talking about here, when we made this reading of 4.20, well, let's go back to one of the earlier ones, a little simpler one. One of the first readings we had was like 4.7 meters, correct, using that top ruler. But that's in meter units. If we did the math to convert that to kilometers, then that would be dividing by 1,000, and that would be 0.0047 kilometers. Different unit, changes the number. Where did these zeros come from? The conversion of the unit. Were these zeros ever measured originally? No, they're just there as placeholders. We measured the 4 and the 7. And so even after we've changed the unit, it's still the 4 and the 7 that are your real measured quantities. Leading zeros never count. Emphasis on never. Those are not going to be significant figures. Those are merely placeholders. They go in and out of the math. Middle zeros, this would be like something that comes in between two other numbers, like 703. If somebody measured the hundreds place and they also measured the ones place, then they had to have measured everything in between, correct? So middle zeros always count as significant figures. They are real measured quantities that just happen to turn out to be zeros. So leading zeros never count, middle zeros always count. So those two rules are absolute. It's these trailing ones you got to think about, because this is where it's a little awkward. The other two rules are absolute, so they're not so bad. But the trailing ones you got to think about, because they're either there for precision or they're there as placeholders. So this would be something like 14,000 or 0.14000. Let's just go with that. With 14,000, and we focus in on those zeros to see whether they are precision or magnitude. If we took those zeros away, would that change the value of the number? Yes. Yeah, now it's 14, not 14,000, right? So those are there to tell you the decimal belongs right about here. Those are placeholders. Those are not real measured quantities. Those are merely to locate the decimal. Not significant figures. In the lower one, 0.14000, if you struck out those zeros, would that change the numerical value? Then what's the point in even writing? Precision. The difference between these two numbers is this one has a little variation in that 4, but this one has a little variation way out there at the 5th decimal place. The bottom one, 0.14, is reliable to 2 decimals, but the one above it is reliable out to the 5th decimal place. That's a tremendously precise measurement. Those zeros reflect precision, and therefore they do count as significant figures. All 5 of those digits are significant figures because they're there for precision purposes. Okay? Question with that? That is the awkward part. It takes getting used to. One other little note here with this, a little notation thing. Sometimes you'll see 14,000 like that. And other times you may see it written like this. Now, having that decimal very deliberately dotted in doesn't tell you anything you didn't already know, because we kind of suspected it was there anyway, right? That's how we knew it was 14,000. We knew that that's where the decimal belonged. But this is a notation thing telling you that everything out to that decimal really was measured. And it just happened to turn out to be zeros. So 14,000 is only two significant figures, but 14,000 decimal, those are real. Those zeros are real measured quantities, and they are significant figures. That's a quirky little notation thing, but it's important. Do you see the difference and what the decimal is used for there? All right. Question about that? Question?
Can you explain that one more time?
About the difference? When you see that decimal reported in the number, it's trying to tell you that everything all the way up to that point was really measured. Not estimated, and not placeholders that come in from shifting the units, but they're real measured quantities. And so a lot of times you'll see that written in there to tell you that those trailing zeros do count. Because both of these have the same numerical value, correct? Putting in the decimal doesn't tell you anything you didn't already know about the numerical value. It's just there to tell you the precision of that value. All right. Question. All right, everybody turn around and wave at Matt. Matt is your SI instructor. And as far as I had mentioned, as far as preparing materials, what time I'm available, I'm more than happy to help you. But Matt has been through Chem 1 and Chem 2. He's been doing peer tutoring for quite a while. He's an excellent resource for this. So if I'm not available, maybe sometimes even if I am available, you may prefer to get in touch with Matt. All right, Matt's an excellent resource for you. So come on up, and he's got some, going to talk to you and got some forms for you to fill out. But please make use of Matt's availability. He's got my old exams. He knows my habits and things. So if you're looking for insider tips,
taking one of
Matt's your
these
guy.
and passing the rest back. I'm going to introduce myself, put my contact info up here. So my name is Matt Oates. If you take Chem 2 with Dr. Burns in the spring, you'll probably see me again. Oh man, I forget about the people in the back.
I write sloppy, but at least I can.
Yeah.
My penmanship does not get any better, so just you'll get accustomed to it over time. My pictures are even worse.
As Dr. Burns said, I'm going to be your SI. That is my cell phone, so don't blow it up at 2 in the morning because I'm going to ignore you, and then I will never answer your text again. No, just don't wake me up really early. I'm full-time in school just like you all are. I'm at UT though. Chemistry major, did it. So I have had Chem 1, I actually had Chem 2 with him in Iceland, so, and I've taken this class in SI for it many other times. So definitely answer your questions. If I can't, I will refer you back to him because he has the knowledge of all things chemistry. You will definitely succeed if you come and get involved early. Have students that wait until like mid-semester and then come get help. We may still be able to help you, but you're not going to do as well and you're not going to be as likely to succeed if you don't start early. So starting early, come and seeing me, Dr. Burns. They're very limited on the people in the tutoring center this semester. They had a bunch of people that kind of dispersed onto greener pastures. So definitely seeing me or Dr. Burns will get you set up. And the forms you're filling out there will actually tell me the times that you have available. So take your class schedule, take a couple minutes right now, X the times you do have available. Anything you leave blank, I'm going to assume that you have a class or work or some other engagement. What I will do is I'll take all these, compile them and find the most popular times, and that's the times that I'll have SI sessions. So our SI sessions will go over problems from the study pack, any material you have any questions about, just really anything in general. It's time for you all to come and ask questions. Well, answer. First 2 weeks. First 2 weeks. If you all will check your emails or D2L, he's going to put me on D2L. I'll put a course news at the top with the time slots that'll be for this week. I'd like to have them up tomorrow, maybe Wednesday before I get them up. So if I get them up Wednesday, I'll put them on the board Wednesday for class. And then when you do get them filled out, if you'll pass them towards the center.
There is free tutoring in the ERC. As Matt said, it's a little bit limited, but it's also a little bit more general than what you would get with Matt. I'm probably not supposed to say that Matt is better than the ones over there, but I'm going to anyway. If for no other reason than he's done this before, and so he knows what's more important than what, and he's going to explain it to you in a fashion that works. Whereas the people over there, you could ask 3 different people and get 3 different methods on how to work something. When you're really just trying to get comfortable with one way to consistently do it. So. If you're able at all, I would highly recommend you go see Matt, in preference to other tutoring, if that is possible. But the other tutoring is certainly good.
Because I use your methods.
And mine are obviously better.
That's right. If you don't have it done, if you need a little bit longer, that's fine. Just sit back there on the desk until you get ready to leave. What you need more time to work on.
Any questions for Matt or about the SI program in general? All right. The next thing in the notes is about following significant figures through a series of calculations. Put a little star by that heading. This is taking other people's data that's given to you on paper and going through it in a series of calculations, and you want to be able to express the answer to that calculation in proper significant figures. There's 2 rules for this. You have to treat addition and subtraction differently from multiplication and division. And we'll talk about each rule and we'll talk about why. But for now, that top row of calculations across through there that starts with 5 plus 3. Take your calculator, do those calculations, write down exactly what your calculator tells you, and then we'll go back and make comparisons. This should be what you got. We're going to go back and look at each one of those in terms of phrasing it in proper significant figures. The addition and subtraction rule is based entirely on place value. At what place value, first decimal, second decimal, third decimal, maybe it's even on the tens or hundreds, but at what place value do the numbers cease to be reliable? Now, 5 plus 3 is obviously 8, right? Not much to quibble about with that one. But, and we can be pretty confident of that, right? Even without a calculator, 5 plus 3 is 8. But look at this one. 5 plus 3 is 8, yeah. The calculator says the total is going to be 8.8. But how confident can you be that 8 plus something that was never measured is still 8? You don't know what would have been there at that first decimal place if it had been measured. Maybe it'd be a 0, maybe it'd be a 1. You don't know what it would be.